Hey everyone, this is Evgeny and I welcome you in another video about LangGraph. So basically, when we were watching our LangGraph introduction series, we were watching the concept human in the loop, and it was very theoretical level. Like I show you how to check it, that how to break the graph and do all this stuff. And today we are going to take a look at the real example, but with some limitations. So join me. Okay, so here is what we are constructing. This is a very simple UI application. It's a real one. I opened it at localhost 3000, and this is the graph we are using here. And take a look, we have an assistant draft. So in general, the idea that we do have an assistant who helps us to perform some job, maybe to create an email or to reply to a comment or something. And we do have this human feedback where we can correct the answer and ask assistant to create the better version. And this is how our graph looks like. So we do have a request here in the start node. It goes to assistant draft where assistant creates a draft for us. Then we stopping here and we have this interrupt before. And the node is human feedback. So here we can decide if we are fine with the result, then we approve it, and it goes to assistant finalize node, which kind of preparing for us the final version, maybe polishing it or something else. Doesn't matter at the moment. We are looking in the concept, in the interruption and human feedback concept. And after finalizing, assistant sends us back the final result. Or if you're not happy with something and this node human feedback, we can reject it and ask, provide some feedback information, and it goes back to assistant draft, and then draft creates another version and then goes back to feedback, and then we can decide again. So this is the very simple graph, right? All right, and just to demonstrate you how it works, we have this ask a question, and for example, we can say, or what is human in the loop, for example, and we send it to our draft, to assistant draft node. And here we can see that this was an initial request, and the assistant generates the answer for us. And so we have some very lengthy explanation about human in the loop concept, and we can either approve it and then it goes to the finalization stage, or we can send feedback and ask to rewrite something. So let's give it a try and provide some feedback, which could be, for example, I want to be a very short explanation, and I'm submitting the feedback. And here we have our feedback this time and what I wrote. And here we are, we have the better version from assistant, and the same, we have a send feedback, or we can approve it. And when I approve it, it goes to finalization, and at the end we have the final version, and the whole cycle is finished. So this is the basic example we are going to work on today. And as I mentioned before, it's a very basic version. It's a lot of limitations for simplicity, for making only the first step in this direction. So what's so restrictable here? First of all, we don't have the graph running in a normal production mode, like as a separated deployment module, for example. So we don't have this as a deployment model, we don't have Redis, we don't have Postgres SQL as needed components for the graph. Instead, we run our graph in embedded mode, like the one we were using in our previous lessons. And so for we are providing an API here, we're using FastAPI for Python. And since we are providing here embedded mode, then probably you noted this already, that we are not using any streaming in place, right? It's kind of a blocking call. We make a call request to our graph and then get back the full result. We're not streaming back, right? And so also the same, our API would be in very restrictive mode. It would be blocking HTML calls, like REST HTML calls. We are not doing any WebSockets. We are not doing any polling strategies, just very simple schema here, right? And on top we have very simple UI that could show us the details of that. So let's take a look at the implementation. Okay, and here I would propose we are progressing very slowly, step by step, and my recommendation would be to start from Python notebook so we can check and see how different smaller parts of the graph work. And here we are, we have our notebook with all the prepared information already, and this is the code for our graph. So maybe first let me compile it here. And you see exactly the same what we saw in the application, right? So we have an assistant draft, we have human feedback and assistant finalizing, and it goes to the end and then we finished. And what do we have here? We are defining our model. That's pretty clear. Like just basically I'm going to repeat part of the previous lesson about graphs and about setting an end breakpoint and how to configure it. But anyway, kind of a refresher. We do have our model, and this is draft review state, and this is based on messages state from LangGraph, which means it contains a list of messages like the whole conversation. We do have a human request as a string, we do have a human comment, and it's optional one, and this is kind of a feedback mechanism. If you want to provide some feedback back, you have to fill this human comment. And we do have a status, it can be approved or feedback, and we do have the assistant response. This is something we are going to, like, this is the result of our work of the round when we run the graph, right? And so we have number of nodes, and this is assistant draft. And here, what's interesting, we do have two kind of forks, two flows. And if you think about that, we are talking about this assistant graph, right? And the reason why we have it, because when we're just starting, it's about creation something, and this is one flow, and when we send back a feedback, then this is kind of already fixing already existing information, so it's another flow. So based on that, we do have different system messages, and we have different kind of the way of generating all the messages. And so what you can see here, like if this is a feedback, it's kind of the second flow already, and we do have a human comment. Then what's happening? We are saying that, okay, then you have to review the feedback and update your reply accordingly. And then we are generating the list of messages. So we're grabbing all the previous conversation plus human comment. Otherwise, if this is the first round, then we're saying, okay, your goal is to fully understand the request and create a relative response here. Right, and everything else is pretty straightforward. We're making a call to our model with the messages. We're collecting a list of all messages for history, so for the next round we clear what was the conversation here, and we are returning back all the content we gathered so far. Next thing, we have this human feedback. We're just passing through because this is the one, it's kind of a placeholder where we are marking that human feedback happens here. And we have very simple assistant finalizing, and it says just, okay, you have the final response, and your idea is just to review it again and maybe polish it somewhere, change the tone, maybe completeness, something else, just very basic stuff. Probably in the prod we don't need this, but just for demonstration, we're showing that, okay, there is another processing after the approval process finished. And the interesting thing here, we do have this router function, which is a conditional routing, and what's happening there, we do have a status in our model, and this one was here. It's either approved or feedback, and based on the status, we are redirecting either to finalization, so approval happened, or we're asking to rewrite based on our feedback and comments. So we're going to assistant draft. And the rest is pretty straightforward and simple. We do have some nodes, we have some ages, we have a conditional age with the feedback router we saw it already, and everything that happens automatically. Right, and so we have this graph. All right, let's give it a try, and I compiled the graph already. It's here, graph, and I'm asking, explain what is human in the loop concept, and I'm defining a new thread. And just let's run the graph and see the result. And again, my expectation would be that we are stopping here at human feedback node because we do have interrupt before. and this one is defined here, right? So we have a result and a lot of information. We do have assistant response, this pretty lengthy explanation about human in the loop concept we saw already, and some metadata as well, and some configuration data and list of messages, like everything in one place. And again, I demonstrated that previously we can ask for a state of a graph, and we do have this state snapshot. And here, if we look for the next, it's this one, we can see that it was interrupted, the graph was interrupted, and then the next node would be human feedback, right? And this is happening because we have this interrupt before human feedback, and this one, and so we stop somewhere here at the top right. So far so good. How should we proceed, right? Let's assume we do have a feedback. So we have to update the current state, so we are changing the status to feedback, and we leave in the feedback itself. So make your answer one sentence short. So we're updating the state of the graph, and then we are just resuming it. And again, the way you resume the graph, you are not providing any state because we do have it already in the graph. We just pass in the config, which define the thread ID, and we say none, which means please resume the graph. And so we have it here, and if you look at that assistant response, we have a very short version of it, like one sentence long this time, right? So it was taken, our feedback was taken, and the response was adopted to this. And this time, let's say, okay, we are fine with that. And again, by the way, we stopped again at this human feedback, right? Because what's happening here, we send our feedback back, system draft created a shorter version and moved it to here, to human feedback, and again we stopped here. And this time, let's approve the result like we like everything, so we can finalize it. Alright, and for doing that, what we need to do, we are changing the status of the graph to approved. And again, we're resuming the graph. Right. And we can print the final state of the graph, right? It's the same, like a lot of information here. And if you check it here, you can see that next is empty, which means the graph finished till the end. So this is the expected behavior here, right? And so we do have our graph here. We kind of double check that everything is working fine. And well, what else can we do? As a next state, we can give it a try in the studio and just visually see that everything is working as expected. So for doing that, I created the folder studio here. I copied the graph itself. I defined the LangGraph JSON as the definition of the only graph we have. I added some requirements, and now we are ready to run the studio and check the graph there. And so here we are, we have the same graphical representation, but this time in studio. We do have our schema here as well, and we can start like a new thread already created. And we can start just asking or sending a new human request here, like what is human in the loop concept. I'm submitted it, and it goes to assistant draft. The first version is created. Okay, now it's created right now. Okay, and we are stopped at human feedback, and you can see it here, right? And this is the thing, if I just click on continue, I will not update the state, so it's not clear how to what happens here, right? We need to update the status, and for this one I'm saying I do have a feedback, and my comment would be make it shorter, and then we go back to assistant draft as expected. And then the model processes our feedback and creates another version. And this time, let's say I'm fine with the result, and I approve it. So I'm saying status is approved, and I'm submitting it again. So we are at finalizing, and we are finished here, right? So everything works as expected, looks like, and we can move to the next step. And what could be our next step? Well, basically we can create our own API, and practically, if you think about that, we need only two endpoints. First, like what kind of activities we have here. First of all, we do have the start conversation thing, like start graph, and then second one, we need to resume it. So these two endpoints we need to create using FastAPI. And for doing that, let's take a look. First of all, I copy pasted the graph itself here again because we are going to use it in embedded mode. So we are going to run it in a normal way, like I showed already in the notebook. And the same, just we do have a model, we have the same nodes, we have the same routing function as well, and then we are creating the graph, right? And we are exporting graph itself and the state, so we can check the graph current, the current situation where our graph is, right? All right, what else? We do have an API, and here I'm defining two endpoints. It's a graph start, as I mentioned already, and we should have a way how to resume the graph. And then we are using the same functionality like run graph and response. And what's happening here? Take a look at that. We do have a graph. We make an invocation using the state and the configuration, and then we just generate the response. And what's happening here, first of all, we grab the current graph state, and then we check if next node is existing, and if this is a human feedback one, then okay, the run status is user feedback. So user feedback is expected, and like our graph stopped and expects us to provide a user feedback. Otherwise, we are saying, okay, graph was finished. And we're just generating the graph response object, and this one we send back to the client. And here, first of all, for starting the graph, what we have here, we'll start a new thread ID, right? We are creating a configuration and the initial message as well, like we have human request, and we pass it from the request we get from the client, and then we run the graph and return in the state. And practically the same for resuming. We do have, again, we creating a configuration, and this time client should provide us thread ID because, well, client need to show us or to ping us to the right graph based on thread ID. We have a status as well, and this status comes from the client. It's kind of, client has to decide either there is a feedback and we need to resume our graph, or there is approval already and then we can continue our graph. Like in both cases, we do have a resume, but anyway, the different flows, right? And if human feedback is here, then we set it as well, and then we just updating the graph state as you saw already, and again we do this invocation, and we are passing none as a status because we are resuming the graph. So that's it, pretty easy, right? Clear. And well, what's next? Next, probably I would test it using Curl or some other HTTP client. Maybe we can just grab it from the Swagger API, which is built kind of thing in this FastAPI, and give it a try and see how it works. And basically, when you run your application using FastAPI, you do have this Swagger built-in support, and it's there. It's the same like 8000 port and /docs, and then you can see all the endpoints created. So here we define two, the one for starting the graph and the one for resuming the graph, and we have some schema objects as well. Like you can go and learn it through, like what kind of information is needed. And let's start the conversation. The beauty thing here, we can give it a try just from this API, from this UI thing, and we can try it out, and that's it, right? We are starting a new graph. We do have this request body, human request, and we're asking the same kind of request. Explain what is human in the loop concept. Okay, concept. A question mark, and I click on execution, and so the API call happens, and it takes some time. It's not really so fast as its name, like FastAPI says. And this is the kind of response we have, right? We have this thread ID, which was assigned automatically. We stop, like graph stopped somewhere in the middle. That's expected, right? We have the user feedback as a status. And we have the assistant response. This, again, pretty lengthy thing, right? We are not going to read it through. But what we are interested in here, we need to know this thread ID for resuming the graph. All right, then let's open another window here, and we want to resume the graph and try it out again. And here we have this thread ID as string, and we have it from the previous conversation. The review action should be feedback. Let me just quickly grab it from our models. Request, it's a feedback. So we do have a feedback here. And the human comment would be kind of, let's give it another comment. This time, like, I want to be 2 years old kid, and I want still to understand what's that, right? So I'm clicking on execution, and again it takes some time, right? And finally we have this one, right? It's the same thread ID. We still stopped at user feedback because no one approved that yet, and we do have an updated response. Like, it's like when you play a game with a friend and sometimes something happens. So kind of for 2-year-old kids, right? And finally, let's assume we are fine with that. So we don't need to define any human comment here, and the action should be approved. Like, we are fine with this. I'm executing it again, resuming the graph again from this current state. And again, it takes some time, and look at that. We have run status to finished, and this is our final response. So this is how it works. This is like kind of API you can use to create your UI, and this UI can talk to this API. Everything's fine, right? So that's probably it for today's lesson. You saw it, how you can combine and merge all the things together. The LangGraph graph is the breaking points. Then you can create your very simple API, and then you can build UI on the top. Like, for example, you can create a service. We have ReactJS, and just you do your stuff here, and then creating some very nicely looking UI, right? And again, it was very limited version. We run our graph in embedded mode. This is not a production reality. In production, you'd run it as a separate deployment, and your FastAPI would be talking to the graph probably with another calls, HTTP calls. And basically we get the whole response, and the ideal situation would be to have here kind of streaming, so you can immediately show the result to the user. But for that also you need to implement something on top of your API. So it's not an API and RESTful API call, but it's more about WebSockets or maybe polling, periodical polling or something. But we can take a look at that later with kind of more complex example. All right, that was it. I hope it was clear for you, or it's more clear now how to combine all these things together. It's not so synthetic example of graph working and stopping somewhere, but you can imagine doing something real which looks like, which brings some value at the end. And it was me, Evgeny. Thanks a lot for watching this video till the end. I really appreciate it. And leave your comments. If you have any questions, please leave your questions as well, because the more questions you have, the more videos we can make to clear this for you. And well, see you next time in the next video. Thank you and take care. Bye bye.